Assalamu alaikum dear students. Today we are going to discuss the algebra of functions, or simply the algebra of two functions. Algebra means addition, subtraction, multiplication or division. Now addition of two real functions. Real functions means those functions whose domain is set of real numbers or subset of real numbers. Now if we have two functions, let's assume that we have two functions f and g, where f is a function from x to r, where x is the domain, or simply the subset of r, where we can define f, where f is defined. Similarly, g is the function from x to r. So this means that we have two functions from same set. We have two functions whose domain is same, and both are the real functions or the real valued functions. Then we can define their sum function, and sum function is again a function. So sum function is again a function which is denoted by f plus g, which is a function from the same domain, that is from x to r, defined by f plus g of x equals to fx plus g of x. So this means that if we have to add up two functions, it is again a function, or the resultant function becomes the function is again a function which is a function whose domain is same as that of the individual functions. Like if we consider x square and g of x is x plus 1, so this means that here we have two functions, both are defined on r, or the domain of these two functions is set r. So this means that here x is r. So actually here f is a function from r to r, g is function from r to r. Then we can have your sum function, and the sum function is simply denoted by f plus g of x, that is f plus g of x, which is equals to fx plus g of x. Fx is x square, g of x is x plus 1. So this means that here this is a new function, x square plus x plus 1. This is the resultant function, or this is a sum function of two functions, f plus g. It is a function, it is a polynomial. You know that the polynomials are defined over entire this set of real numbers. Hence this is the new function. This is a sum function. Its domain is same as that of f as well as g. Here this equal domain for f and g is important. If f and g are two functions with different domains, like f has domain equals to x or a, if we consider f to be a function whose domain is a, means f is dependent on a, g is function from g is the function on b, that is defined on b, where a is not equals to b, they are not equal sets, then we cannot define f plus g. Then we cannot define here f plus g, sorry, here it is f plus g is not defined. We can define f plus g when both domains are same. Similarly, we can have the subtraction function. Subtraction function, you can simply replace here plus by minus. Equal domains for f and g are important in this subtraction also, and we can define subtraction function from, suppose, at x to r as f minus g of x equals to fx minus g of x, fx minus g of x, as we define f plus g or f plus g of x. Now the second one is the multiplication of two functions. Here we have two types of multiplication. One is simply the scalar multiplication, second one is simple multiplication. Scalar means constant. Now here we are dealing with the real functions, or we are discussing the real functions or real valued functions. So let's consider a real function. Real function means domain is subset or the set R, where a is the subset of R. So this means that here we are considering that a real function, and lambda is R. Lambda belongs to R, means lambda is the constant, scalar or the constant. Then the scalar multiplication of f. Now this is the given function, we have to multiply this function with this constant, that is called scalar multiplication. Now when we multiply this function by a scalar, it becomes the new function, and the new function is denoted by lambda f, which is again a function from the same set to R, that is from a to R, because domain of the given f is a. So this means that domain of the lambda f becomes simply a, which is defined by lambda f of x is equal to lambda into f of x. Like f of x is x plus 1. 5 is constant. So this means that 5 is here. The scalar means 5 equals to lambda. 5 f of x is nothing but it is a function which is defined by 5 into f of x, that is x plus 1, because f of x is x plus 1, that is 5x plus 5. So this means that here 5x plus 5 is nothing but it is the scalar multiplication of 5, that is scalar, and the function f, which is x plus 1. Now the second multiplication is simply the simple multiplication. In this analysis, we simply call this multiplication as the pointwise multiplication. What is meant by pointwise multiplication? If we have two functions like f is a function from a to a, g is the function from a to a, here domain, equality of domains is important. Then we can define the product function or the multiplication function. F into g is the function from same set from a to r defined by f into g of x, that is f dot g of x equals to fx into g of x. Like if we consider f of x equals to x plus 1, g of x is x square, then both are defined on r, then their multiplication or the pointwise multiplication is simply f into g of x is fx into g of x, that is x plus 1 into x square, which is x cube plus x square. So this is here x cube plus x square. It is again a function which is the polynomial because it has the degree. It is a polynomial. It is defined on r. So this means that this is the multiplication of two functions. One is x plus 1 minus f. Second one is x square minus g. Here in this multiplication, subtraction, and in addition of two functions, equality of domains is necessary or must. We can define if domains of two functions or three functions or n functions are equal, we can define their sum, we can define their subtraction, or we can define their multiplication. But if domains are unequal, we cannot define, or these operations or this algebra is not well defined. Now the last one is quotient of two functions. Quotient means division. If we have two functions f from a to r, g from a to r, equality of domain, then we can have f by g, which is a function from subset a of r. Here a1 is subset of a, so that this means that we are restricting the domain of the new function or the resultant function. What is this? This function is defined from a1 to r as f by g of x equals to f of x upon g of x, where a1 is that subset of a where g of x is not equals to 0, where g of x is not equals to 0. So this means that we have to pick up those points, or we have to remove those points from the given domain where the function, second function means the denominator function, becomes 0, the resting becomes the domain of this quotient function. Why we need this? Because if we consider non-zero upon zero term, non-zero upon zero term means it is not defined in r, because it is infinity, that is why we have to consider those points where this becomes the finite number. Like if like we define the rational is p upon q, where p and q are integers, q is not equals to 0. Same concept is here. Like if we consider two functions f of x equals to x, g of x is x plus 1, both are defined from r to r, their domain is r. If we define their quotient function, it is f by g of x equals to fx into g, fx by g of x, which is x upon x plus 1. So this means that this here we have to restrict the domain of f by g, means quotient function, because g of x is a function which is equals to 0 at x equals to 1, or the 0 of this function is x equals to 1, because if we put x equals to minus 1 in this equation, in this function, its value becomes 0. So this means that we have to remove the minus 1 from the domain. When we remove the minus 1, that removing minus 1 from or is the domain is actually a becomes r minus 1. We have to remove this one from this this becomes the new domain, and this is the subset of the given domain. So in this way you can define the quotient function of any two functions. Inshallah, in tomorrow video lecture we will discuss few more important concepts on this algebra of two functions. So thank you.